Hello, I'm Jens Alfke from Couchbase, and this is my second talk here. This time I'm going to be talking more in depth about the CouchCocoa framework that's used in Couchbase Mobile for iOS, and particularly using it for representing the object model of your application. Let's see, let me get to slide 2. Okay, so being that this is my second talk, let's just review some of the higher level stuff that I'm going to be assuming that you already know. This is talking about Couchbase Mobile, which is a mobile product based on Apache CouchDB technology, which means it's a NoSQL database, document-oriented, there's no schema, it's very straightforward. And in particular, the really killer thing about CouchDB and Couchbase Mobile is the sync capability, which lets multiple instances of it replicate changes to each other. So Couchbase Mobile is using this technology embedded in a framework that you can put into your mobile app, either on iOS or on Android. The iOS version is ready, the 2.0 release we call it, even though there was never a 1.0. It's available. The Android one is still in beta, but pretty solid. And I've included a URL there for where to get the iOS version from. So Couchbase Mobile and CouchDB have this API that's based on REST. That is, it's over HTTP requests since this started out as a server product. And the document model, the data model that it has is based on JSON, which is similar to Cocoa property lists, but not quite the same. On the other hand, your application, your iOS or Mac application is using Objective-C APIs, and it has an object model that, of course, is going to be using Objective-C methods and properties. So the question then is, how do we bridge those two? And that's where the CouchCocoa framework comes in. So this is an Objective-C framework that we wrote that basically talks to the CouchDB API over HTTP and exposes all that stuff as a bunch of Objective-C classes and methods. At a low level, it takes these HTTP REST type requests and maps them into the operation objects, which can be sent either synchronously or asynchronously, which is the async mode is really good for responsiveness in your UI, since you don't want to block up your UI while you're talking to the database. And it also takes these concepts of documents, queries, servers, etc., and maps them to Objective-C classes. The JSON documents get represented as NS dictionaries, sort of the same way that property lists are represented. So you have dictionaries that can contain other dictionaries or arrays or NS values, and so on. But the problem with this is that NS dictionary is not a good object model. It's pretty awkward to work with if you're going to be using it for your everyday tasks. So for example, using an NS dictionary to get out some kind of integer-based property, you'd be calling object for key on the name and then getting the int value to convert that NS number object into a real number. Whereas if you were using a regular integer-valued property, you'd just say dot grade, whatever the property name is. So the first version, too long, too awkward, too error-prone, because you might end up misspelling the property name or thinking it was supposed to be a grade level or something like that, and you won't get any sort of compile time warning about it. So we like the second one. That's good. We want to work with that. So we think, okay, we can take this CouchDB, CouchCocoa document and wrap it in a custom Objective-C class. So you can see here we've got sort of a skeleton of that where we've got a class whose instances remember which document they're from and have a dictionary, a mutable dictionary storing the properties. And then we're going to expose those properties as Objective-C properties using the app property syntax. The problem then is that to implement those properties, you have to put in a whole bunch of boilerplate. So we've got that same expression we had before, object for key, int value in the getter, which, okay, that's nice because the clients using this class won't have to be doing that stuff, but at least we have to paste one of these in for every property we want to use in every class. And the setter goes the other direction. It's going to wrap this int value into an NS number object and store it in the dictionary. And some people are okay with pasting in lots of boilerplate, and there are even applications that will paste in boilerplate for you, but I, for one, really hate it. anytime I see stuff like this where I have to keep on copying and pasting the same thing over again, I keep thinking of like, how can the framework do this for me? In addition, that's not the only problem that you have with creating an object model class if you wanted to try doing this. So you need to have a one-to-one association of model objects to documents so that you don't have lots of different models lying around for the same document that you might be making incompatible changes to. You need to keep a copy of the document's properties as a mutable collection since the document itself is immutable. Then when changes are made, you have to remember to save them, but you don't want to issue a put request after every single property change, or that could get very inefficient if you're going to change a bunch of properties at once. If there was an external change to the document, like if there's a sync happening in the background and the Couchbase has pulled down a bunch of new changes, you want to be able to update your model object when that happens. And you need to be able to create new model objects that don't have a document associated with them yet because there's something new that hasn't been saved yet. So this, and finally then there's attachments, which I'll get into a little bit later, which are sort of binary blobs that you can stick onto your documents, which are very useful but a little bit hard to manage in a model class. So as I said, let's let the framework do the hard stuff. This is what I think of whenever I'm using a framework and something complicated happens, that why can't we push this complexity down into the framework so that the clients will have an easier job. So let's look a little bit at what exactly a kind of generic model class would need to do. This is a very kind of standard type of diagram. It doesn't just apply to Couchbase Mobile, or it could apply to any sort of database or even a file-based system where step one is that we want to load some document out of storage, database, file, whatever, into a model object. Then our views and controllers are going to be accessing properties of this model object to display the UI. Then as the user makes changes, the same views and controllers are going to be pushing changes into the model. And then finally, at some point, you want to save those those changes persistently, so the model is going to save itself back out to the document, whatever that is. Okay, so we have this Couch model class in the CouchCocoa framework, which I found some people actually aren't aware of yet because it was a later addition to the framework after the initial releases of it, but it's been around for a while. Couch model, so it's part of CouchCocoa. It basically does all these things, and I've tagged them with the same numbers there. So you can get the model object for a document, and every time you call that on the same document, you'll get the same model object back, so it's one-to-one. Or you can create a model for a new document in a database, and it won't actually get saved out to a Couchbase document until you save it. We then have the getters and setters for properties, get value of property, set value of property. And then finally, we have a save command to save the model object back to the document. There's also this very handy property called autosaves. If you turn that on, you don't have to call save explicitly. The model object, whenever you make a change to it, it will remind itself to call save soon, quote, soon, unquote. And that means that if you change a bunch of properties in a row, all of those changes will happen in memory before that save call happens. So the save will end up saving them all in one batch. But now I promised you these magic properties where you could define them using nice Objective-C property syntax, and it would do the work of converting them into objects for you. Let's go into that. So this slide shows what we want to be able to do. So we want to be able to define some class we're calling student, which inherits from Couch model. I hope you can see that slide because it is not showing up in the right side of my window. But and the student has a couple of properties that we've defined using the Objective-C syntax. It's got an NS string one called name, it's got an integer one called grade, and it's one whose value is an NS date called permanent record last updated. Now the implementation for this is really, really easy. We just use this magic Objective-C syntax called @dynamic and list those properties. And what this means, I'll get into it a little bit more in the next slide, but basically this just means something is going to take care of implementing the methods for these properties. You don't have to worry about it. And this is how you would use it. So on the first line, we get a couch document. We're assuming that we already knew the document ID, so we get the document. We get the model object from it, and we're calling model for document on the student class here, so we're going to get back a student object. We tell it we want it to autosave to make things simple. And now we can just access the grade. We can change that date valued property, and that will all get saved out for us. Groovy. So what about this @dynamic thing? This slide is optional, but I think some people will be curious about it. I definitely was. So at compile time, all @dynamic means is it tells the compiler to shut up about the fact that there isn't any implementation for this property. Ordinarily, you'd get a compile error, of course, saying, hey, you defined this property, but you didn't implement it. @dynamic just means like, yeah, don't worry about it. So what happens then? So at runtime, some client code is going to access like the grade property on this object, which means that it's going to call the method grade. And there isn't any such method because we didn't create one. So what happens then is that the Objective-C runtime sends this kind of panic message to the class saying, hey, there's supposed to be a method for this property, and there isn't one. And that method then has the ability to create a new method and add it to the class on the fly. And the runtime will then go ahead and call that method. And so there's an implementation of this in Couch model that actually grabs the property metadata, says, oh, look, this property is called grade. Its value is supposed to be an int. So we're going to cook up a method that accesses this key called grade out of the document and maps the value to an int and returns it. And then it plugs that into the class. The nice thing is that even though that behavior is sort of complex, it only happens once. After that, there really is a method in the class called grade, a perfectly ordinary method, and it will then just get called normally. So there's pretty low overhead after the first time the method is accessed. Okay, end of digression. So the property types that you can use this with are pretty much what you'd expect, the basic kind of scalar integer types. Booleans, both the all caps bool that you're used to from Cocoa and the lowercase bool, which has been in C++ for a long time. It is actually in C as well, in C99. I'll get into those a little bit more. Raw NS numbers, if you don't feel like having the framework map it into a scalar for you, you can use that. NS null, although having a property whose type is NS null would be kind of pointless. Strings, arrays, dictionaries, standard JSON or property list types that you're used to. And NS data and NS date, which are oddballs in that they're supported by property lists and they're very useful and common, but they're not actually natively supported in JSON. So we'll get to that in a little bit. And the way that these get mapped to JSON is that the numeric types obviously get just turned into JSON numbers. The lowercase bool type will map into true and false. NS number objects will map into either a plain number or true and false. So if you used like NS number with Boolean, then the value that will go into the JSON is actually going to be the true or false instead of a numeric value. NS null, of course, maps to a null value in JSON. NS data, there's some special magic inside of Couch model that will convert this into a base 64 encoded string because JSON doesn't actually have the capability to represent binary data. So it's convenient to store this, although you get like a 25% expansion in size and it's a little bit more expensive. Attachments are a good alternative to this. I'll get into those later. NS date, again, JSON doesn't have a date representation, so this will get converted into a string in the ISO 8601 date format, which seems to be kind of the de facto format for storing dates in JavaScript and JSON. And this goes both ways, right? So if you have a value with an encoded date in the JSON in the document, then it will get read in and converted to an NS date for you. So there are some gotchas involved in all this. Not everything works perfectly smoothly, of course. With Boolean values, there's this interesting difference between lowercase and uppercase bool, which usually is not very significant, but happens to be here. So as I said before, the lowercase bool type will properly map into true and false. The uppercase bool type, that's the one that you use everywhere in Cocoa, will instead map into 0 and 1, which isn't quite ideal. And the reason for this is because the Cocoa frameworks are very old. They started back in the 80s before there was any sort of native Boolean type. So they just used a type def for it. And so if you look at the definition of all caps bool, it's really just a type def for char, for the character type. So that means that the compiler and the runtime pretty much can't tell the difference between uppercase bool and char. It just looks like an 8-bit integer type to them. So the kind of introspection that the Couch model uses can't see that you're actually declaring a property as having a Boolean value instead of having an integer value. So again, the workaround for that is to use the lowercase bool type for your properties, which does get recognized by the compiler. And nowadays, there's no problem using it in Objective-C code, even if you don't have C++ enabled, because the C99 standard supports it. The scalars and null. So obviously, the C scalar types, by which I mean integers, floats, booleans, etc., they don't have a null value. The closest thing that they have is a 0. So that means that if you have a JSON document that has a value of null or has no value at all for a property that you've declared as an integer, the value that you're going to get back is 0. So you can't actually tell the difference between there being a 0 value and the property being missing entirely. And most of the time you really don't care, but there may be times when you do, in which case you'd kind of need to think about that. Also, this means that there's no way to remove that property entirely. So if you set the value to 0, that means that the property is going to get written out in JSON just with a value of 0. You actually can't get rid of the property from the JSON entirely that way. The workaround for this is pretty simple. So you can drop down to the lower level API that I showed in the first slide about Couch model, the get value of property and set value of property. And those take an ID, just an object. So you can just wrap the number that you want, or the nil, in an NS number and pass it in. So if you stick in a value of 0, set a value of nil for that, it will actually delete the property entirely. And when you get the property value, then you can tell the difference between a nil result, which means there's no property at all, or an NS number that happens to have a value of 0 in it. This isn't something that comes up a lot, but there are some times you may run into some kind of schema people have used for their document design where there's a difference between a value of 0 and a value not being in there at all. Okay, so there's type mismatches. This one is a little bit nasty. So the fact that you've declared a property in your Objective-C class as having an integer value doesn't mean that the actual JSON document that gets read in is going to have an integer value for that property. You hope that it does, but you can't guarantee it. So if you have a document where that value actually happens to be a string or an array, and then you're trying to access a numeric valued property, you're going to get some kind of exception, probably like message not understood or something like that, which would be bad news for your app. It's kind of an especially bad problem if you're in a situation where you can't trust the contents of your database, which may be kind of a weird concept if you're thinking of the database as just being something that you use locally. But there are cases where, for example, if your database is synced with some database up in the cloud, and there are actually multiple users who have access to that database, like it's some kind of maybe a shared whiteboard or a wiki or something like that. This means that other users can be making changes and pushing them up to the cloud, and then you pull those changes down, and basically since they didn't come from you, you cannot trust them. You should not assume that everything in there is perfectly valid and hunky-dory just because it's in your database. In that case, it would be kind of nasty if your application could suddenly start throwing exceptions or crashing because somebody pushed a value that had an unexpected type. The best workaround for this is actually a regular Couchbase CouchDB feature, which is that you can set a validation function in your database in a design document, which is a function that will get called on every document that is going to get inserted in, either locally or through replication. And the function can look at the document. It can even look at the previous revision if it wants to. And it gets to basically return true or false. It can fail that document if it doesn't look right. So one use for this is to double check the type of every single value in there, saying, okay, this grade property, if it exists, is its value an NS number? And if it's not, then you fail. Or you could say that if this property is missing, we're going to fail, or if it doesn't, isn't compatible with the previous value of the property in a previous revision, then we're going to fail, et cetera, et cetera. So security people will tell you that validation is always good. It's really important to validate your data, especially if it's coming potentially off of the network. And that's the level at which that validation should be happening. You could put it in your model, but it means that you would have to start, you wouldn't be able to use the magic property stuff anymore. You'd have to write your own property handling code and do a bunch of defensive type checking, and that's going to slow down your code. So another gotcha is about contents of collections. So this kind of magic transformation of data and date objects doesn't happen. It only happens to your top level properties. It doesn't happen to stuff inside of NS arrays and NS dictionaries. So if you have a property whose value is an NS array, you can't really go around stuffing dates into there. So here's an example, and I apologize for the very slow typing speed. This was actually going a lot faster in the original keynote presentation, but something happened in the conversion. So anyway, so we have a property whose type is NSDate, or actually it's an array of dates. And so we take a date and we wrap it in the NS array and shove it into that property, and then we save, which is not actually going to work. So it'll work fine at the point where you set the property value, but when you save, it's going to go blam. What will likely happen is that Cocoa's JSON encoder will barf because it doesn't know how to encode NS dates. And that's because Couch model didn't go through and detect the NS date that you put in there and convert it into a string for you. It's possible CouchCocoa could do this in the future. It seems like it might get a little expensive, but it's possible. So what you should do instead is do the conversion yourself, which fortunately isn't that difficult. So again, here in the slow typing, we are calling this nice class method on REST body that will take an NS date and convert it into a string for us. And then we put that string into an array and put that into the date property and save. And that works fine. The converse of this, of course, is that if you're accessing a property whose value is an array and you're expecting to find NS dates or NS data objects inside of it, that's not going to work. So instead, you're going to find strings whose values are date format strings or base64 encoded data. And again, you'll need to use these convenience methods on REST body to decode them for you. Okay, next topic is about attachments, which I mentioned really briefly. These are a good alternative to storing NS data inside of your document. So general stuff about CouchDB/Couchbase and attachments. They're a much more efficient way of handling large binary data in documents. And they're more efficient because they're loaded on demand. So when you fetch a document, normally if it has attachments, you don't get the attachment value. In the document you can see the metadata about the attachments, like what they're named and what their MIME types are and how big they are, but you don't actually pull down the attachments themselves, which is great because you may want to fetch 1,000 documents in a query, and you're not going to want to deal with the attachments for all of those right then. Another benefit of attachments is that if you start making a lot of changes to these documents, then the new contents of the documents will get stored in the database, and because of the way that Couchbase works, the new revisions get appended to the database, and not until compaction occurs later on will the older revisions get cleaned up. So the attachments are not duplicated every time you save a new revision. So as long as you haven't changed the attachment, it's not going to get rewritten into the file. So there's a lot less file writing and file appending going on for that. Also, attachments can be sent and received directly in binary form without any encoding into base64. And that means that you save something like 25% overhead in the amount of bytes transferred, and you save yourself the CPU overhead of encoding into and out of base 64. Attachments come tagged with a MIME type, which is nice in case you need to remember later on what format this data was in. And also, every attachment to a document has its own URL, which is sort of like a child URL of the document's URL. And that means that you can access these attachments using standard HTTP GETs, which is pretty cool, actually, because that means that you could get the URL of an attachment, and you could just, like, if you have an UI image view or an NS image view, you can just tell it to load that URL. Or even if you stuff some HTTP into HTML into an attachment, you could shove that into a UI web view and have it loaded and displayed. It's pretty cool. So how do we do attachments in Couch Model? It's pretty straightforward. CouchCocoa already has a class called CouchAttachment that is the API for working with attachments. So in Couch Model, we have a property called attachment names that just gives you the names of all the attachments. And given one of those names, you can call attachment named and get back the couch attachment for it. And from the couch attachment, which I'm not showing here in this slide, you can find out its MIME type, you can find out its size, you can get its URL, you can fetch its data, exactly what you'd expect. If you want to add an attachment or overwrite an existing attachment in a model, then you can just call create attachment with name, pass in a name, content type, and just raw data for the body. So despite being called create, this also, it could be like create and overwrite, or create or overwrite, because if you already have an attachment, it will just replace it. And finally, there's remove attachment named if you just want to delete the attachment completely. Now the tricky bit here, at least tricky bit in the implementation, is that these have the same semantics as changing properties in the model, which is that this happens in memory. Nothing actually gets written to the database until the model gets saved. So typically, if you were to work with an attachment on a Couch document, as soon as you create the attachment, that's actually going to generate a post or a put to the document and write it into the database. Couch Model, instead, when you call these methods, is going to save up those changes in memory until it's saving the document, and then it will save the new attachment changes along with the document atomically. So here's a quick example of attachments. So let's say we've got our student class, and we want to extend that student class to be able to store an image, like a mugshot of the student. So we declare a property whose value type is UI image. And then we implement the property like this. So in the getter, we're going to ask for the attachment named mugshot.jpg. It's just some arbitrary name that we made up. Now, you don't have to put a suffix on the attachment name, like the .jpg here. It can be useful if you end up later passing the attachment's URL to something, so that something might be using the file name extension to decide what type it is. But you don't have to do that. If there's no attachment by that name, we just return nil. Otherwise, we construct a UI image object on the data, the body of the attachment, and return it. Now, in a real application, or depending on how often the mugshot gets accessed, we might want to cache that UI image object as an instance variable. But I'll leave that as an exercise for the reader. The setter is pretty straightforward, too. So if we're setting the mugshot to nil, like no image at all, then we call remove attachment with the same name. Otherwise, we call UI image JPEG representation to get JPEG data representing that image. And then we create, again, or overwrite the attachment with our name and pass in the data type, which is image/JPEG, and the data. And that's it. So what might be happening in the future? I think this is already pretty cool, and it does a lot of useful stuff, but there's always more things that you can do. One thing that would be nice is if there were a better way of telling the modeling system which model class you want to use for which document. So currently, the class that you get, the model subclass that you get, depends on which model subclass you ask to get the document. That is, if you say student, model with document blah, you'll get back a student. If you call teacher document model with blah, you'll get back a teacher object. So you kind of have to know ahead of time which class you want before you ask for it. What would be better would be some mechanism where we could use this convention that's used a lot in CouchDB and Couchbase, where you have a type property in your document whose value indicates what type of thing it is. So a student might have type colon quote student unquote. Teacher might have type colon quote teacher unquote. So maybe we could have something you can set up once where you say, when you see a type property whose value is student, then please instantiate a student object. Alternatively, and more flexibly, there might be a function or a block that you could register that gets to peek at the document and look at its properties and decide which class to instantiate. Another thing which I'm kind of working on already is relationships between models. So that would just mean that you define a property whose value type is an object that is a subclass of Couch model. So in the student example, again, we could declare who the teacher of this student is. And we would make its property type be teacher, whereas somewhere else we have declared teacher as being a subclass of Couch model. So what Couch model would do with that is it would get the value of the property and expect it to be a document ID, and then grab the document with that ID, grab the model object from it, and return that. So that means in the document itself, the teacher property would be some string that would probably have some like big messy UUID that was the ID of the corresponding teacher object. But if you were working with it in Couch model, you would just like get the teacher property and have the nice model object already there for you. There is some experimental support for this in the latest trunk revision, latest Git revisions of CouchCocoa. It's not in the version of CouchCocoa that's packaged in the 2.0 release, but if you are interested in playing with this, you can go and check out CouchCocoa from GitHub and try it out. Another good feature to have would be bulk save. So right now, every model is sort of independently in charge of saving itself. What happens then is that if you were to create or modify a whole bunch of model objects, like you go through every student and change update their grades or something like that, you're going to generate one put request to the database for every model object that you changed. And obviously that's not going to scale terribly well. You probably won't notice problems with it unless you start getting into really large numbers of changes, but eventually you will. So a better approach would be to have something like probably at the database level that would keep track of all of the model objects that are currently marked as having been modified and want to be saved. And then that thing would grab all of the saved data together and call this already existing method on Couch database called put changes to revisions, which in turn ends up calling this REST API called bulk save, which will write all of the changes to all of the documents in one call. And this is much more efficient if you have a large number of documents. I'm sort of partway through implementing this. It appears to work, but I want to test it some more before I check it in. And that is about the end of the talk. So hopefully you will find this stuff useful in implementing your own applications. I certainly have. This was one of the first things that I ran into when I started using the very early builds of CouchCocoa to build little sample apps with, like the little sample grocery store app or so on, that it was a pain to work with the raw dictionaries from the documents. And so I wanted to make a class that would let me represent them as real objects. And eventually, after a couple of revisions, that grew into the real Couch model class, which I hope that you will find useful too. And that is the end of the official part of my talk. And so now I guess I'll be available to answer questions if you have questions.
Thank you very much, Jens, for that terrific presentation. We do have a few questions that came in. Are you able to see them under that Q&A tab?
They're not showing up right now. Oh yeah, here, I just refreshed the tab and now they're showing up. Okay, so first question, does the API allow me to persist raw JSON by REST if I need to? Yes, you don't have to use Couch model at all if you don't want. The lower level Couch document class represents the document as an NS dictionary and will let you save it that way. If you want to go even lower level, then there is a method called putJSON, which is inherited from the base class of Couch document, which is called REST resource, that will just let you shove raw JSON in. And everything should work. So even if you bypass all this stuff and save changes that way, the document and the model should still be able to keep up. They'll notice that you changed it. Next question, does the HTTP GET method of accessing attachments support Apple's HTTP live streaming protocol? That's a really interesting question, and I'm going to have to say that I have no idea. I remember hearing about the live streaming protocol from watching WWDC sessions, when was it, last year? But I don't remember the details of it. And so if that protocol does not require server support, then it should work, because you can just add multiple attachments, like you can break your video or whatever resource into multiple attachments in the document. And assuming that the protocol just requires them to have like a magic naming structure or a magic metadata file or something like that, it should work. If there is server support necessary, then my guess is that it wouldn't work straight out of the box, but you might be able to hook in some stuff to fake it. But I really don't know the details. Feel free to ask that on the mobile Couchbase mailing list if you want to start a conversation about that. Next question, can we talk about SSL and on-device data encryption? Any pointers to that topic? Yeah, that is a really interesting topic. So there is SSL support in Couchbase Mobile 2.0. It was, I think, the last feature that got added to it. So you can replicate to and from a remote database over SSL, which is, of course, really important. It's a little bit limited in that there's certificate support. It doesn't really tie into the OS's certificate handling, so you will probably need to get the public key cert of the server that you want to talk to and bundle it into your application. On-device data encryption, that has come up a couple of times before. I know that's a big deal especially for healthcare applications, because there are federal laws that require healthcare data to be encrypted at all points. This is something I've been meaning to look at. There is a facility in iOS for telling the OS to encrypt files for you. And you can even tell it, like, I want this file to be encrypted anytime the device is locked, or anytime my application quits, or anytime my application goes into the background. And I suspect that if you did that to the underlying database file in the Couchbase down at the server level, that it would work. But I'm not certain. It kind of depends on how the OS does the encryption. So that's something that still needs to be looked into. And I know also that the engineers here who work on the actual Couchbase database itself have talked about the potential of like having hooks down at the low file read and write level that would allow for doing encrypting and decrypting the data before it hits the disk. But that's just something I've been talking about. There isn't actually any implementation of that yet. And then the last question that I have on my list here, have you considered adding an isProperty set helper to do the lower level get as NS number and then compare to nil? Yeah, that would definitely be a good convenience. It would sort of be equivalent to calling get property value and saying, is that equal to nil? But I'm all in favor of having convenience methods that have a more mnemonic name to make your code easier to read. So I'll check to see, let me refresh to see if any questions came in. I think that is all the questions.